Hi, I am going to burn two big latex balloons, one filled with butane, the other filled with pure hydrogen. I start by inflating first balloon with pure hydrogen. Before inflating the balloon, I add a small amount of HI float solution to the balloon, a fantastic product I've recently discovered that keeps helium or hydrogen-filled latex balloons inflated far longer. I spread the product well. I am going to inflate this first balloon with pure hydrogen. Hydrogen that I obtained by electrolysis of water. This electrolyzer produces approximately 150 liters of hydrogen for a consumption of 1 kilowatt-hour. I have here a large blue mylar balloon filled with pure hydrogen. I am going to transfer the gas into the latex balloon. For this I use a mini pump bought from AliExpress. Hydrogen is the lightest and most abundant gas in the universe. 2 times lighter than helium. Its combustion produces water vapor, and only water vapor. A big balloon filled with pure hydrogen. I measure the circumference to deduce the volume. The circumference is over 150 centimeters, I would say around 165 centimeters. Assuming the balloon is spherical, we deduce that its volume is about 75 liters. Let's inflate the second balloon with butane. Before inflating, I treat the latex envelope with HIFloat product. This is essential because the balloon would deflate very quickly otherwise. Much faster than the one filled with hydrogen. As we will see, inflating a balloon with butane is a bad idea. I recommend you do not repeat this. Butane is a very dense gas, it is also a hydrocarbon. Its combustion produces water and carbon dioxide, a greenhouse gas. But if the air does not provide enough oxygen, combustion is incomplete and produces carbon or even carbon monoxide, a colorless, odorless, but deadly gas. Both balloons are ready. The next morning I go out to burn them. The outdoor conditions are ideal, no wind and high humidity in the air and soil, eliminating any risk of fire. I measure the circumference of the balloon. The circumference of the balloon is just over 150 centimeters. Assuming the balloon is spherical, we deduce that its volume is about 60 liters. 60 liters of butane ready to be burned. Now time to burn hydrogen-filled balloon. It is a little bigger than the previous balloon. Will it be more impressive or not? We'll see right away. As we see, it is very different. It's much more instantaneous, but much less impressive. Very interesting. Here's why it's less impressive. Hydrogen has a very high energy per mass, about 120 megajoules per kilogram, or 33 kilowatt-hours per kilogram. But hydrogen is very light, about 85 grams per cubic meter under normal conditions. We deduce that for 1 cubic meter of hydrogen, we have an energy of 2.8 kilowatt-hours. What about butane? Energy per mass of butane is about 46 megajoules per kilogram, or 12.7 kilowatt-hours per kilogram. But butane is very dense, about 2,500 grams per cubic meter under normal conditions. We deduce that for 1 cubic meter of butane, we have an energy of 31.4 kilowatt-hours. That's about 11 times more than hydrogen. Let's summarize. At equivalent volume, butane releases approximately 11 times more energy than hydrogen upon combustion. Soon, I will show how I adapted a gas stove to run on hydrogen. Green hydrogen, of course. We will see how many Breton crepes I can cook with this big balloon. Stay tuned.